All right, so chemistry of life is sensitive to acidic and basic conditions. So fluids inside and outside of cells contain a great number of dissolved ions, which can influence the structure and function of cells. Hydrogen ions are the most abundant and most influential of these ions. A lot of times you'll see a H and a plus. The plus means that they're positively charged ions of hydrogen. At any given moment in liquid water, there are some molecules that break apart. And when they break apart, one of the hydrogen ions breaks off. So you have a hydrogen ion, and then you have what's left is a hydroxide ion, which has an oxygen and a hydrogen, and that is going to be negatively charged. When that water molecule is breaking apart, at the same time there is a hydrogen ion being attached to a hydroxide ion to form a water molecule. All right. So at any given time you have this breaking apart and putting together, but there's no net gain or loss of these hydrogen ions. You have the same amount all the time. All right. So since these hydrogen ions can influence the function and structure of cells, scientists developed a pH scale that will be that's used to measure the concentrations of hydrogen ions in a solution. All right, and the pH scale ranges from 0. 0 means it has the highest concentration of hydrogen ions, and then 14, which means it has the lowest concentration of hydrogen ions. So 0 to 14. In the middle is pH 7. 7, if the fluid is pH 7, that means it's neutral. It has the same concentration of hydrogen ions and hydroxide ions. Most of the water inside cells and outside cells are pH 7. Water out in the environment, for instance around Lawrenceburg or Lexington, we have higher concentrations of calcium, and this calcium rich water is actually absorbs some of the hydrogen ions. So as it absorbs some of the hydrogen ions, it takes them out. You have lower pH a higher pH than normal neutral conditions. And so pH around Lexington, in, for instance, Elkhorn Creek, could be around 8. All right, so a little higher pH. That's because there are less hydrogen ions than hydroxide ions. So acids are substances that donate hydrogen ions into solutions. Bases are substances that accept or take out hydrogen ions from a solution. So if you have a solution that has a pH that has a higher concentration of hydrogen ions, by probably adding an acid, right, then the pH goes down below 7, and when it does, you have an acidic solution. A basic solution is where you have a lower concentration of hydrogen ions, and the pH is going to be above 7. So from pH 7 to 0 are acidic solutions. Solutions that have pH 7 to 14 are basic solutions. You can put substances in solution that help resist the changes of pH, and these these work by either accepting hydrogen ions or donating hydrogen ions, depending on the condition that exists. So Mr. Brumley is making you take a exam number 1, and you're studying all night before, and you get tired and hungry, and so you decide to go get something to eat. So you drive down the road, and off in the distance is this white glow, and you get closer and closer, and you see the castle of white, and you run in through the drive-through and get 15 White Castle sliders. Oh, and you eat them on the way home, so they're gone by the time you get back to your house. And for a while everything is great, but then your stomach starts churning and burning and wow, right? And so what has happened is the beautiful White Castles have started donating hydrogen ions into the solution in your stomach, because the solution in your stomach is actually hydrochloric acid, and it does have a pH below 7. So, because what happens when you vomit, right? When you vomit, your throat gets exposed to the acidic solution, and it causes it to burn, right? And so you have a lower pH in your stomach, but those White Castles are just lowering the pH, so it starts to burn. And so what you do is grab a roll of ROLAIDs. You put them into your stomach, and those Rolaids actually start accepting some of the hydrogen ions and take them out of solution, so that the pH goes back up to its normal pH, right? And so that is a buffer, right? A buffer helps maintain a certain pH. So here's a pH scale. You can see pH of 1 to 14, and you can see neutral water is at 7, or pure water. If you start adding hydrogen ions, you go from urine and saliva to black coffee to acid rain, which is in the 5 range, to carbonic acid, which is in your Coca-Cola, right? There's hydrochloric acid, which is down in the 3s. Gastric acid, see there, pH 2, all right? Battery acid, pH 1. If you go to the opposite side of neutral, you've got seawater has a pH of a little higher than 7. Baking soda, milk of magnesia, ammonia, soapy water, pH 12. Look at bleach, 13, and then drain cleaner is 14. Drain cleaner is made of sodium hydroxide, right? Sodium hydroxide is also the molecule that makes up a substance called lye. Lye was used as a soap by early Americans. It was a dry form of sodium hydroxide, and it was used as soap. And when we think of acids, we think of substances that can burn, right? But a lot of times we don't think of bases or alkaline. Base and alkaline are the same thing. Bases as being able to burn. The ability to burn of a substance is called whether it's caustic or not, right? And a lot of acids are caustic, but bases are as well. And so lye, the soap, sodium hydroxide, was used to clean people just like we had bar soap now, and it actually did clean the dead cells off the top of the epidermis because it burned them off. A lot of times you have a soapy feel to your skin if you get a little bit of sodium hydroxide on your skin, and that's because it's burning the outer layer of your skin cells. So pH. And then lastly, we talked about the formation of bonds, all right, and but as we get molecules together, these molecules are put together by things called chemical reactions, and these are just the combination of atoms to form molecules, and these molecules to form even larger or bigger molecules. And so chemical reactions are the foundation of life. Most of the molecules that are important to life are very large, and so they have to be, these smaller molecules have to be put together to form these larger molecules. And the process by which this is done is a chemical reaction, and it leads to to chemical change of matter, the way molecules combine to form more complex molecules and substances, right? So basically, you'll see certain diagrams and written out, all right? You're not going to have to know a lot of these chemical abbreviations or anything, but there are a few basic chemical reactions that we will look at and know. And in the case of water, if you take two hydrogen molecules, and you add those to oxygen, you'll get two water molecules, right? So what you start with, those molecules are called reactants, and then the molecules that you end up with are called products. You will always have a arrow pointing from the reactants toward the products. And so there is a question on your exam. I'll give you a chemical reaction like the one there with a 2H2 plus O2, and then arrow pointing to 2H2O, and I'll ask you what are the H2 and the O2s, those are the reactants, and what is the H2Os, what are the H2Os, and those are the products, right? So that in the summary of chapter 2. So we'll talk about any questions or specifics you might have on our next class period.